All right, Josh and I were talking, we were chatting, we were having a great time. Then he talked about a trip he took to Australia where he did not die, but he said he had great coffee. And I said, hey, I'm from New Orleans, don't talk to me about coffee. You know what that dude said? New Orleans got good coffee? They out here, bruh. How many people understand New Orleans has the best coffee? Portland and Seattle can get out my face. Y'all understand it's the best? Like, when you put in the spoon, it just stays up. Like, there's no liquid to our coffee. It's strong and it's beautiful. Who's had New Orleans coffee? There you go. There you go, bro. That's all right. But we're going to like Josh anyway. The most important thing, he adopted a kitten. But he didn't tell me the name of the kitten, so he can tell y'all that. He just started baking. He bakes pies. Did not tell me what kind. Didn't offer a brother nothing. But that's all right. Even with that, we're going to like him anyway. Bang your hands together for the cool, awesome Josh Goldberg.
Hi, everyone. I'm Josh Goldberg. I am a TypeScript developer. Right now, I'm an open source maintainer. I work on projects, some of which you may use, some of which you should stop using, some of which I'd like you to start using. I'm also the author of the Learning TypeScript O'Reilly book, which is a great way to learn TypeScript. Buy it now, please, maybe after my talk, and an organizer of Conf, which is a friend of Magnolia because we love this conference. We love Kayla and Richard and all the people. Let's give a warm round of applause to Kayla and Richard and all the volunteers and other organizers for setting this up. I'm so happy to be here. Thanks for having me. Oh, very exciting. I'm here to answer some of the concerns and questions that most of us, myself included, have had around TypeScript, which all can be boiled down to a feeling, a vibe, a statement that I've heard so many times. TypeScript made me do it. If we've worked in TypeScript long enough, we've all done things that we regret because TypeScript gave us these red squigglies or errors or whatnot that just are upsetting. And it feels like TypeScript is this disciplinarian wizard that you have to throw your stuff in front of and beg, and maybe it'll let you pass to the next stage, or maybe TypeScript will yell at you and then throw you down into the pits of, I don't know, fire. It's not great. But you should feel in control of TypeScript because TypeScript does not control you. It's not TypeScript's choice what you do with your code. TypeScript is a tool. And just like any other dev tool that we use, we are in control of our tooling. And I would really like to show you all today a bunch of tips and tricks and treats for how to work effectively with TypeScript to feel like you're in control. So we're going to cover a little bit of intro to TypeScript, and then we're going to cover 6 fun ways, paired mostly with real-world bugs that we can use TypeScript to make our code better and our lives better. Specifically, I will show you 3 treats, 3 cool things TypeScript can do for you, and then 3 tricks of the trade, 3 ways to hold TypeScript in a way that works well. Are we ready and excited? Yes. Or we could go back to the TypeScript puns. Nope? All right. How does TypeScript work? Let's open the door in this way. How does TypeScript think about the code that it's looking at, that we've written? This is the core principle of TypeScript. TypeScript understands the type of every variable, every function, class, whatever construct in your code. And then later on, step 2, whenever you use that construct, whenever you access a property, call a function, assign something to a variable, TypeScript checks, are you using it the way that type described it to be allowed? Does your actual usage match the intent of your code? Let's take a look at a quick example. Let's say I have a variable, let value equals Magnolia, and then 50-50 chance I either assign it a string or a number. Does anyone have memorized the TypeScript type error that'll happen if you do this code? Shout it out. No one. I'll give you a hint. It's this. Type number is not assignable to type string. This X is not assignable to Y is the most common pain point for writing things with TypeScript. But it makes sense. We never said that this variable could be a number. There are ways to do that. But we only ever gave it an initial value of string, which means TypeScript thinks the intent behind this variable is string. This is the core runtime, the way that TypeScript does things. Let's say that we have a different variable, value, which is either a string or a number. This is what's called a union type. It's either or. It comes from math. I'm not great at math, but if you like, yeah, math, yeah, Kenneth. If you like math, this comes from the concept of set theory. It's a set of two. Now, if you try to call .2 uppercase on value, that's going to give you a TypeScript complaint because 2 uppercase does not exist on the union type. It's either spooky or 1337. It's maybe going to have a 2 uppercase. We don't know. And this brings up another cool TypeScript feature called narrowing. I have a speech impediment around R's and W's, so when I say narrowing, it is difficult, so please forgive my mispronunciations. Narrowing is when TypeScript sees that a certain area of code can only be run if a very specific condition is met. In this case, the condition is that value is a string, which means TypeScript is smart enough to understand that inside the if statement, value is not string or number. It's not spooky or 1337. It's only ever spooky, the literal string spooky. That's a pretty nifty trick. Most programming languages don't do that for you. Now, narrowing is great because here's an example of a bug, kind of bug that you might see in code. Let's say that you call to some function, maybe the global fetch, that sometimes throws an error and sometimes gives back a result. If you're one of those fancy schmancy new functional developers using effect, you have thoughts on this, but we're not functional programmers in this talk. This might log, I have, let's say, /counts gives some number. I might have 10 items or 20. But does anyone know what it's going to log if the fetch fails, if you're offline or the API is an error or some such? Anyone want to take a guess? Please, someone just shout something. I feel so bad when... Yeah, who said nan? Nan. Thank you, yes. It'll say I have nan items because count will be undefined, and undefined times 2 is not a number. Great. And TypeScript will let us know, because TypeScript did not narrow down count. Had we checked if count is a number, if type of count equals, quote, number, then it would have been able to narrow down, and we would have avoided the bug. So yay TypeScript and yay type narrowing. Woo. Thanks. Sometimes narrowing does not work as expected. Why is TypeScript like this often boils down to, why doesn't TypeScript like what I'm doing? Why does it think the variable is this type when I know it's that type? Let's look at an example. In this code, we know that after assigning value a string, scary, it is a string. This is fine. This code does not produce TypeScript complaints. But if you have a function that sets value, and then you call that function, nope, TypeScript yells at you. Why is that? The answer is because functions are confusing and impossible to keep track of, or at least way too difficult for TypeScript to do. TypeScript does not respect narrowing across function boundaries like this. If you have a function that does some side effect, TypeScript is not going to factor in that side effect. In order to do that, it would have to read every line of the function and understand everything that that function calls to see all the list of side effects, and that's a colossal task and prone to error, so TypeScript just won't do it. Stop asking. And an example of how that gets really hard is, let's say you have, this is kind of like a React code base or Solid or some similar thing, and you have this complex flow where like there's a function that sets the value and the function is called by some JSX prop and then the value might exist in real time. You and I, if we were to all look at this code long enough, we would be able to conclude that this is fine. That value is only ever a string when form on submit is called because it's only ever called when we have typed in some value. That's too much. TypeScript ain't gonna go do that for you. TypeScript just says value is undefined. As a general rule of thumb, if you're ever doing complex, convoluted stuff to the point where TypeScript doesn't understand what you're doing, my advice would be to simplify. In this case, I'm not going to show you using the latest and greatest form library, but if you're ever writing forms in your front-end code, I would recommend using a library. They do a lot of cool stuff for you and help you work well with TypeScript. So the first treat that we have here is write clear, predictable code, because that way TypeScript won't yell at you. Or in other words, so that TypeScript can understand your code and give you better development assistance. Yay. Moving on. TypeScript might understand your variable as an object, and it might have a different understanding than you of what properties exist on that object. Let's say that you have spooky code you want to react to some entity. Happy Halloween month, everyone. And you might want to say, OK, the entity might have died. It might have a residence. It might be like a ghost. Or it might have an age, like maybe it's some vampire that's 300 years old. And it might be a daywalker. If anyone here is diving deep into vampire lore, that's an important delineation. So you might say, if the then okay, we know that it has a residence because that's a ghost, and we might log, woo, ghost. This is not going to be allowed by TypeScript because we have said in this second property, residence question mark string, saying residence might not exist, it might be undefined. So TypeScript is rightfully going to tell us, look, I don't care about entity.died. All I know is that entity.residence might be undefined, and if you run this code, undefined residence, it's going to crash. That's not okay. Now, the root issue here is that entity.residence might be undefined, and you can work around it in a couple ways. You can use the exclamation mark as the non-null, that's a TypeScript feature that says, shut up TypeScript, I know what I'm doing. This is definitely assigned, it's not null. Or you could use the JavaScript operator, the question mark, that says, if this exists, access the property or call the function. Otherwise, give me back undefined. And I got to be honest with you, I tend to mistake those sometimes if I haven't coded for long enough. It's just one character. So I want to be very clear that there is a very distinct difference, a very clear delineation between these two. The question mark is a runtime thing. It's a JavaScript operator. It's built into JavaScript. It's called optional chaining. And the exclamation mark is a TypeScript thing, a non-null assertion. And on the left, you see the question mark actually is the equivalent of, if it's null or undefined, give undefined, otherwise to uppercase, roughly give or take. And on the right, it's just a TypeScript thing that gets erased. It's just JavaScript at the end. But these are kind of working around the type system. These are telling the type system, no, shut up, you're wrong. Or it's adding a case in runtime, which would mean that we call log with woo undefined. And neither of those is ideal. I would posit that a better strategy here is to precisely, not just accurately, but precisely describe what's going on using our types. So here's how I would start to rewrite this. I would use a union type, so it could be either or. And I would split the two entity concepts into two interfaces, a ghost interface and a vampire. So oh, I missed it on the vampire, whoops. I redid my transition this morning like a maniac. We know that if it's a ghost, it has died and residence. And if it's a vampire, it has age and date. But TypeScript's going to yell at us because an entity that's either a ghost or vampire, we don't actually know what's on this, so we can't access properties. We're not sure what those types are. This is TypeScript being a little strict, a little safeguarding-y for us. So what I would maybe then do is use an as assertion, which is another way of telling TypeScript, shut up, you're wrong, I know what I'm doing. I'm going to pretend this is a ghost. I'm going to check if this is a ghost, then it has a died. So using it like a ghost, we can then access residence. This is still kind of working around TypeScript. And in general, whenever you start using words like assertion and phrases like shut up TypeScript, I know what I'm doing, you're probably working around TypeScript in ways that aren't safe. So what I would introduce maybe then is a type predicate. It's a function that takes in some argument, some parameter, and returns a special Boolean. That Boolean tells the type checker that this thing is definitely that particular type. That if this is ghost function returns true, then we know entity is ghost, which allows TypeScript to type narrow. Because if is ghost entity is true, that's the only way that that if statement gets hit. Yay! No type errors. And if you really want to get advanced and fancy with TypeScript, if you really want to dive deep into TypeScript lore, you can use what's called a discriminated type. No one likes that name. Please don't ask me if we found a better name. We haven't. If you have a better name for this, please let me know. But it comes from the mathematical concept of discrimination, again, UG, meaning using some property to delineate between two or more things. In this case, the type property is a discriminant, meaning if type is ghost, the string literal ghost, we know it's a spooky ghost. And if type is a, quote, vampire string, we know it's an eerie vampire. So if entity.type triple equal ghost, that can be used to narrow down the type of entity. That's cool stuff. That combines objects and narrowing and literals and all this stuff. And I think it's really cool. I think it's great. But you don't have to know this stuff to be a TypeScript developer. There's one last thing I want to show you. This thing, I mess up constantly, and it's totally fine if you're already kind of losing it. That's fine. But looping over objects. Who here has looped over an object in their JavaScript code in the last 6 months? Half the room very cautiously raising. Thank you, Will, for the confidence in raising your hand. This is fine. This is totally fine if your decorations object only ever has these string and number value pairs. pumpkins and skeletons. But TypeScript would get you with this kind of convoluted, objectively, I think, overly convoluted error message. So I'm just going to pretend that what it says is this. Expression of type string can't be used to index type decorations. What it's saying is that for const key means that key is type string. Any string in the world, pumpkins or skeletons or some other thing, who knows? And the reason why is that TypeScript is a structural type system. This code is actually kind of valid TypeScript. Notice how everything, I'm going to use my mouse here, everything has this extra property, tombstones, woo, spooky. But TypeScript is totally OK with you passing it in to count decorations. And the reason why is TypeScript is structural. It says as long as the object you're giving me satisfies whatever shape you're asking me to use it as, totally fine. Everything has pumpkins and skeletons, so it's fine. Doesn't matter that it has extra tombstones, which is why key is string in the previous example. Now, if we loop over the specific known keys, we want this as const, telling TypeScript it's just those keys, long story. Great, we're happy. Strategy could be to loop over all the values of the object and then only use the number values. TypeScript. Great. So if you do have an object that stores a bunch of key value pairs and you want to loop over it, I would suggest maybe consider using a map instead. This is not TypeScript specific. This is just how JavaScript is designed. I use objects when I know the keys ahead of time and I don't need to loop over them. And I use maps when it could be anything. This example could be rewritten with a map that we're looping over the values of. And if we know that the values might not be always a number, we could just filter to number values. Yay. Thanks, TypeScript. OK. This is rather deep TypeScript stuff, and it's like not even 10 o'clock yet. So let's talk about some of the spooky ghost stuff, the tricks of the trade. Who here has complained or seen someone complain that they cannot preview their changes, they can't run their code because TypeScript has a type error? A few hands. I'm so sorry. That's not how it's supposed to work. It wasn't meant to be like this. That's not how TypeScript is meant to be. If you have some code, and the code has a type error, which this does that I'm not showing yet, but the code just kind of runs, you should be allowed to try the code out. Sometimes TypeScript gives really convoluted errors. Sometimes it's really hard to get the types to match up when you're writing complex stuff and using libraries. So the old way of doing things, using a library like tsnode that both compiles your code to JavaScript and types checks it and runs it, well, if you do it that way, then you're blocked on type errors. Fun fact, this I don't know if anyone caught, it's an array being passed to a thing that says string. And that's just so frustrating because I don't want to have to fix this crap. So what I do instead personally is I will have two things running at once. I'll have TypeScript compiler, that's type checker, running in watch mode. And I'll separately in a different terminal run the code. Node recently added built-in support for just running TypeScript files directly. Previously, you could run the JavaScript files emitted by TSC. But either way, that means that you have two different windows, one that has your type errors, if any, and one that has the result of your code. And if you fix your code, then TSC watch updates, and you can still run it either way. A much better way of living your life. It means you don't have to fix every type error before you preview your code. By the way, the way that Node and a lot of other libraries do this internally is something called type stripping. They just strip out any type-specific syntax. And by strip out, I mean replace spaces. Delete the characters. They replace them with white space. And the reason why I think is so cute, it's because that way you don't have to change your source maps. Because the literal lines and columns of all your characters stay the same. So your source maps, pointing from your minified, uglified output back to the source, still point to the same location. It's like a cute little optimization, even if the files are the same size. OK. Now, most frameworks do this by default. Astro, Remix, Nux, Svelte, Kit, Solid Start, Vite in general, they all build in this methodology. A few don't. For example, Next.js, I have gripes with them. One is that a lot of people see failed pull requests or builds on TypeScript errors. You can turn that off. There's a small vocal minority of us telling them they should do that by default, but it's a whole conversation. You can also tell it to ignore ESLint errors, because they'll also block your builds on ESLint complaints or your production deploys. And if you're doing either or both of these in a separate step in CI or your workflow or whatnot, then it doesn't really make sense to also slow down your Next.js builds on them. So highly recommend these. Tracking should block your merges. I do not recommend merging to main or master or whatever your company calls it with type errors, but allow yourself to try your code out before you fix those type errors. Okay, now you're looking at code, and I bet you're thinking, wow, that's cool stuff. I want to dive in. I want TypeScript to yell at me more. I want more red squigglies. But it's okay. I know one or two of you might be thinking, I want less of that. Get that away from me, dear heavens. And you can do both or either. TypeScript's super configurable. There is a TSConfig file with compiler options that are super lax by default. This code, which has actually multiple issues, fun fact, totally allowed by TypeScript by default if you don't populate any compiler options. Does anyone know what one of the type errors or TypeScript complaints would be if we turned on all the strict stuff? I'll give you a hint. It starts with no implicit. Yeah, no, thank you, no implicit any. I also saw someone nod, and I would have accepted a nod also. No implicit any. No implicit any is bad. Any is the YOLO, I don't know what's going on, just let me do whatever the heck I want type. In general, when working with programming languages, YOLO, just let me do what I want, is not generally best practice. Implicit means you didn't tell TypeScript what this is, and TypeScript can't figure it out from its declaration, so just implicitly, without any input from you, it's any. Any bad, we don't like any. Sometimes you gotta do it, sometimes it's just the only way to get it to run, but most of the time we try to avoid any. And we do that by adding a nice little type annotation. That's one of the common ways. And you can actually have the no implicit any compiler option enabled or disabled. A lot of projects will keep it disabled when they're first converting from JS to TS and then turn it on later. Another great one is strict null checks. We saw this earlier with undefined. Older programming languages often allowed you to pass null or some equivalent thing anywhere you wanted. Something that said it was a string or an array. Pass null, see if I care. That's what's called the $1 billion mistake, because the person who first introduced it suggested it might have caused $1 billion of damage. That term is quite a few years old, and it's probably a lot more than $1 billion at this point. Fun fact, the prompt API in JavaScript gives string or null that TypeScript can catch for you if you want it to. Yay. And you might, I don't know, like do a conditional to make sure you just greet if the user exists. Okay. You can turn all these on with strict true. Strict true is the good way of doing TypeScript, or at least the more powerful way. If you're able to do it, I highly recommend it. Strict turns on a lot of flags. It's really useful. It's a good way of doing things. I'm not going to dive into all of these unless you want to give me a 2-hour time slot next year. But the one that I do want to talk about is use unknown and catch variables, because this comes up a lot. Fun fact about JavaScript, we have no idea what caught errors are. We cannot know their types. And they're, by default, any. Because people can do whatever the hell they want. They can throw strings. You can throw null. You can throw instances of a class named error that is different from the global error, some class you defined yourself. Awful. People do awful things with thrown objects in JavaScript. I've seen it all. Which is why TypeScript can't assume the type of an error. And by default, it's any, but we don't like any because any is permissive and lets you do whatever the hell you want. So with this option turned on by strict called use unknown in catch variables, the type of the error becomes unknown. It's just like any, but very strict. You're not allowed to do anything until you type narrow. For example, with it on, you'd get this complaint by TypeScript, which would encourage you to maybe, I don't know, check if it's an instance of an error. Otherwise, it's, I don't know, just general handling code. Yay. Cool. I'm not going to talk to you more about type2 compiler options or type narrowing, but I do want to show you one quick demo since I have, I believe, 3 or 4 minutes left. I got a vague shrug from Richard. Thanks. There's a lot of stuff you can set up, and TypeScript is in an ecosystem change and a lot of cool tools, and people are experimenting and iterating and doing all this awesome stuff, which means that it can be kind of hard to get the latest and greatest. So I'm going to go ahead and run npx create TypeScript app, which is a tool that I maintain. And what are we going to call our new repo? Give me a name that's appropriate for work. Spooky, scary skeletons. So if you've ever used like a create React app or create Vite or create Next or whatever, this is what it describes. Hooray, Magnolia Conf. Whee! I'm going to start with the common set of tooling. And it's running in offline mode so that it doesn't push to GitHub and take time. But if I wanted to, skeleton. I have too many repos that start with spooky, scary. Shut up, Copilot. So this just created for me a basic TypeScript project. It's got a bunch of compiler options, most of which we don't need to dive into, but I do want to shout out strict true, hooray. Include source, so I'm going to go to source index. And we have like a very basic greet function that takes in a union of options or string. And let's pm build. So this uses tsdown, which is a really nice builder that makes a bunch of files. Oh, they have these little region comments. That's cool. So I'm going to run pm tsc-watch. And oh, look, TypeScript's already done. So let's say that I'm going to introduce a type error. I'm going to switch options to number. And now we have a whole bunch of complaints about property whatever. It doesn't exist on number. Cool. So I'm going to show you, since I have time, a few nice pieces of tooling that come alongside TypeScript. First, let's talk about ESLint. Who here likes linting? Yes! Who here hates linting? Similar, some of the same, okay. All right, well, you might have seen that this got grayed out in the IDE. VS Code and other TypeScript editors will show you visually when something is grayed out. But there's also a linter that you can run. So ESLint can run in something and let you know no unused variables. Also, there are a whole bunch of typed lint rules that come with TypeScript ESLint. That's the TypeScript plugin. Unsafe call of an error typed value on line 11. Logger is type error, meaning we don't know what it is because you have type errors. So the lint rule is letting us know it's unsafe. So that's nice. Someone's watch is beeping, haha. But I want to show you an example of async code. Let's say we have an async function, wait, then log. Let's await new promise, resolve, set timeout, resolve 1000, whatever. Then log, hello, it's David S. Pumpkins. And let's say we wait, then log, and then wait, then log again. Does anyone see the problem? Let's say that I wanted to log twice. Wait a second, log in series. Does anyone see what's wrong here? I'll give you a hint. It's got squigglies, so there's definitely something wrong. Let's zoom in one more time, make sure everyone can see. I'm not handling the promises. Whoever said that, you got it right before the lint rule. This is an example of what's called a floating promise, meaning one that you created and then allowed to just float away into the distance. What you might want to do is either of the things the lint rule suggests, such as adding an await, or adding a void to tell the lint rule, shut up, I know what I'm doing. I'll also show one more nice little rule. It's a little thing called knip here. Oop, lint knip. God dang it. Oh, I didn't put it. You know what? I used the common template, not the everything. So if we run create TypeScript app preset everything, I'm going to upgrade this, and let's keep it in offline mode. I'm going to upgrade this repo to have all sorts of extra tooling on it. And then once that's ready, I'll show you a cool tool called knip. Does anyone know what knip means in Dutch? Cool. It's showing me I have lint complaints in my package JSON because, fun fact, you can lint your package JSON with ESLint now. Josh Goldberg. And now we have a spell checker that's added in. So I'm going to add that. Anyway, PM lint knip. Knip means cut. Their logo is a pair of scissors. And oh, looks like I have an unused thing in my config file. Let's get rid of that. So knip will let me know if I've got some types here that aren't used by anything. Not used. Let's see if knip finds this. It should. Oh, nope. Well, that's a bug. Never mind. That's really unfortunate. That worked yesterday. Anyway, I'm going to ignore that. We're going to pretend that knip told me that this interface isn't used by anyone. So that's fun. But anyway, I'm going to stop talking soon. The general gist of things, I'm very thrown by that. The general gist of thing is that you want to add tools built on TypeScript. TypeScript is an awesome platform. It provides a lot of cool type checking stuff and nice syntax on its own, but it also provides APIs that tools like ESLint and knip and all these new modern linters like OXLint can use. And if your head's not spinning from all the cool information that I just thrown at you, I don't know what's going wrong. Let's recap. I'm almost done. We opened the door in TypeScript. We talked about some 3 treats that you can do with it, some nice bugs it can find for you. We talked about 3 tricks of the trade, cool ways of holding it. Specifically, treats were write clear, predictable code so TypeScript can predict it. Definitely always precisely describe the shapes of your data. And if you know the keys of something, yeah, you can use an object. But if you don't, maybe use a map. For those tricks, type checking should block your merges, but please don't block trying your code out. That's just really frustrating and annoying. Learn TypeScript strict options. They will find surprising bugs for you. And if you can, turn them all on. And lastly, use tools built on TypeScript because they can find a lot of awesome stuff. Even though my demo stopped working apparently this morning, I promise it's a cool demo. If you want to learn more about TypeScript, I wrote a book. And that's all I have for you today. Thanks for watching, everyone.